Assalamualaikum and a very good afternoon. My name is Wan Amira Bashara binti Zainul Abidin. I'm going to present to you the backgated silicon nanowire field effect transistor for detection of dengue virus. Our team members are Associate Professor Dr. Muhammad Nuzaihan Matno, Dr. Muhammad Faris Muhammad Fatil, me Wan Amira Bashara, Aidil Shazirin Azlan, and Associate Professor IR Dr. Muhammad Khairuddin Mat Arshad. As of 11 July 2020, a total of 2,138 dengue cases which caused by the dengue virus have been reported in Malaysia by WHO. Therefore, rapid diagnosis approach for early dengue virus infection is very important as a prevention of an outbreak on a wide scale and reducing severe cases of dengue. A silicon nanowire FET based biosensor are notable for their attractive characteristics such as real-time, highly sensitive and label-free detection of a wide range of biomolecules as well as in detecting a virus. So this one is the backgated silicon nanowire structure, where the starting material that we use here is a P-type silicon on insulator wafer with the thickness of the top silicon is 70 nanometer. The thickness of the buried oxide layer is 145 nanometer. So why we integrate with the backgate? Because it will improve the sensitivity since it will also affect the subthreshold regime. So this device had been fabricated using conventional photolithography and ICPRE. It has a structure of a common field effect transistor, which is drain, gate and source, where the silicon nanowire will act as a transducer that fabricated between source and drain, and having a backgate as an enhancement of the signal produced by the interaction of the. So this one is the methodology, where it will start with the device fabrication using conventional photolithography and HPM inspection, and then the formation of source drain and the transducer of the nanowire. Surface characterization using HPM, SEM, AFM, and then backgate exposure using lithography and wet etch. And then formation of contact pad, source, drain and backgate using lithography, and then the electrical characterization of the backgate biasing using Keithley 6480 picoammeter voltage source and Keithley 2400 source meter, and then move to the surface functionalization using uptest and GA, surface immobilization, probe DNA, surface hybridization using target. As of the first stage of it is the fabrication process. So the fabrication process will start with wafer cleaning by dipping in a BOE to remove native oxide, followed by DI water, and then will blow dry. And then the lithography process using positive photoresist, spin coating via spin coater, and etching, anisotropic silicon layer etching via ICPRE for 21 seconds. Then photolithography for backgate, repeated photolithography process for backgate exposure. So lastly is the deposition of gold nickel. So the second stage is the surface functionalization, where the silicon nanowire will modified with the uptest and using GA as a linker, glutaraldehyde, and then immobilized by using DNA probe, dengue DNA probe, and hybridized by using dengue DNA target. So the third stage is the morphological characterization by using AFM, where we get 163.7 nanometer for the width of the nanowire, and clarify the element composition by using energy dispersive X-ray EDX spectrum of silicon nanowire, where the silicon element is 70.8% and oxygen is 28.2% from the total percentage weight. Therefore, this response makes the nanowire FET ideal candidates for chemical and biological sensing, as the change in the electric field due to binding of a charged molecule to the nanowire surface. So the nanowire have been chosen because it has a 1D nanostructures, so that the particles travel only along the wire direction. This one. And it is highly sensitive, real-time diagnostic and monitoring of disease, fast and easy detection. So the silicon nanowire modified with the DNA probe have used to bind with the targeted DNA, resulting in response of their electrical behavior. So, as a conclusion, the result obtained in this invention shows the reliability in the silicon nanowire field effect transistor for great potential and high performance application, as in medical diagnosis for early detection of dengue DNA detection. The integration with the backgate will enhance the biomolecule signal detection, such as virus or DNA. Thank you. That's all.